Some people may remember this little screen device here that I had. Mounted it into this center thing. I molded it in with a custom printed, I say printed, it's not 3D printed though, it's selective sintering. It's a higher quality so it looks like actual injection mold. But this screen is basically an HMI or a programmable PLC. You can design all sorts of interfaces to it, design your own gauges, stuff like that. It's not a plug-and-play type thing. You actually have to program everything, import your PNGs, overlay different objects, scale them. I mean, it's very intensive, but it's a really nice device if you can get it to program correctly. So I started working on a new layout for this. The old one had a boost gauge on this side. Some may remember from the old videos. There's boost gauge on this side, boost number in the middle, oil pressure on that side with a colored scale, and then a low math and a high math. One thing that's been on my list for a while now is that the low math channel and the high math channel both ran off voltage. The high math channel is actually PWM, so the voltage varied on that depending on flow rate, which gave me an idea of whether or not it was flowing correctly. The low side, on the other hand, also ran that way, but it was through the AEM controller, which sends a voltage signal but no current all the time, and basically made it look like it was running full all the time. So that was a problem I had to get around. So what I did was I installed these two things. These are pressure transducers. So they tie into the methanol supply lines that go up front. And what they do is there's a little tiny diaphragm in there, and depending on the amount of pressure that it exerts on this inside of the diaphragm, it changes the voltage signal that comes out. So it gets a VREF of 5 volts. And depending on how much pressure, it scales between, linear scaling between 0.5 and 4.5. Higher the pressure is, the higher the voltage is, and then the device up front actually tells it how many PSI it's receiving based on that scale. So right now we have one on the low side, one on the high side. This is a dual stage methanol injection. I have it programmed for my own scaling, start, stop, pressure wave, and whatnot. So we'll go back to the front. So now that takes care of the issue with the low channel thinking that it had voltage all the time, which of course it did with the AEM controller, but now we're going to be based on pressure. So I spent a lot of time on this rework, a couple days now. Go ahead and I'll plug it in, fire it up, and we'll see what it looks like here, and then I'll show you on the computer in simulation what it looks like. So the startup screen resolution is actually the same as a PlayStation Portable. A little throwback there. This camera likes to wash colors for some reason, I don't know why, but this screen and it, so the colors aren't true, and I assure you it's a lot sharper than it looks. But you can see there's a green and red thing that are blinking right now. That is for each methanol channel. So if the transducer is reading less than 0 or 0.492, something like that, then that means the VREF voltage for the transducers are not reading correctly, and we know we have an issue. They should read, they will, unless there's an error, but for a little bit of margin, they'll read 0.5 volts at all times. So if for some reason they read less than 0.5 volts, those two alarms there will go off, and the letters in the top left corner, or sorry, top right corner, will turn red. Originally, if there is no error, the left side will be green and the right side will be blue, just like before. And then the same bar scaling is down here under low and high, but right now there's no flow, so we have no bars. And then these will be green if the voltage, again, is 0.5 or above, up in them top right corner numbers. Boost is scaled to go to 0, but it has to have a voltage reference for it to say 0, so it says 2.9. And then this outside purple goes up. On the right side here we have oil pressure. The reason that that's off center is because it's double digit. Once it turns on, it will actually center itself. But as you can see, it's red. So let's take a look at the programming here. So I'm going to go ahead and unplug this because this cord is apparently super cheap. So if we open up the simulator, this is what it looks like here. See if I can get this scaling down. So this is what the screen would look like if the car was actually on. So you can see this is low math channel. So as that goes up and down, this thing, it's a Lascar panel Pilot 43AD, I think it is. has extremely good voltage accuracy and refresh rate. It's in the, like, milliseconds, super quick. That's the real response of it. It can actually read like 5 or 6 digits of accuracy if it wants to, depending on your scaling. But basically the way that this is set up is that this is your flow on a bar for quick reference if you were to quickly do a quick take at it while you're driving. This is percentage of flow, and this is the voltage that is on the transducer. That's more for error feedback for me on the initial install. I'll be able to use that to see and do problem shooting if we need to. But you can see when we get down to VREF of 0.5, that is 0 psi, no flow. If we go below that, 0.49, and then after we break 0.49, it'll turn red, and that bottom left will actually start blinking to let us know that there is an error. So if for some reason I started the car up, this one on startup, since there will be no flow, will actually be at 0.5. If that left side is red, I know that methanol sensor is not working, so that would tell me that my flow is not going to be accurate at all, and I need to check that out. It's kind of like a safety redundancy, and I can tie that into an output that then bypasses the methanol injection pump, or does a detune on boost if I wanted to. But you can see that alerts there, numbers through there. Once it comes back up to the reasonable voltage, it goes back to happy. This one does the exact same thing. Now we get into boost. You can see boost is graphed here. The sensor for this car goes up to some ridiculous amount of boost. It's like 70 something wild like that. They just use the universal sensor that, generally speaking, has a wide range. So what we did is we actually scaled this from 0 pounds of boost up to, I think, 23.5 or something like that. So you can see as the voltage goes up, or I should say as the boost goes up, it goes to there. And what I did was I put alarms on 20. Once it goes above 20, this ring comes alive, the center number turns red. Again, that is for quick referencing, so that you're not staring at a screen while you're driving at a high speed. And I think the max out that I have the scaling on, 23.2 pounds, and that's because most people are not going to be running more than 23.2, and if you are, you may want to look at your head studs. But once you get below that, it goes back to normal, it's all good. You can kind of tell, but it's actually outlined, the numbers are outlined in purple. There's a lot of little hints and cool little things on this. But I got that one set up with the errors. And then the last one is the oil pressure. Normal oil pressure during idle on hot. Once it's hot, it's going to be between 18 and 20 pounds. Stage 1 tops down, I think, at 30, and then stage 2 goes straight to like 60 something. It's a dual stage oil pump. So this is the way it's going to be set up from now on. It's figured I'd share a little. These bars kind of look normal from the screen too, but if you zoom in on them, they actually have a purple overlaid shadow. Same with the high logo and everything else. I tried to come up with a happier route for this bottom thing. I haven't gotten to it yet. I might incorporate some buttons and stuff. Also, this low meth thing that's here is part of the digital I/O configuration. But for some reason, when you go into simulation, it doesn't get rid of it. So that's going to be a feedback for the methanol fuel level in the rear. If the methanol level gets low, then a light comes on and shows you that you have low methanol, and I can also trigger that into an output so that if there's low methanol, it starts to retain things, or more stuff happens. You can put in buttons for brightness, and you can do calculators, trend graph maps, stuff like that. It'll keep track of everything. But just figured I'd show the new design for anybody that wanted to know what it might look like soon.